This question is very similar to solving the heats of reaction. However, a heat of combustion is specifically for fuels being burned in excess oxygen. This is generally the way the question is phrased. You are asked to write out a balanced equation and then calculate the heat of combustion. You are given the values for the heats of formation. Step 1. Write out the balanced equation. Simply write out the reactants and the products and ignore the number of moles for now. Note, you will always have a fuel and oxygen on the reactant side, and you will always get carbon dioxide and water as a product. Now we balance the equation. Start with the carbons first, then the hydrogens, and finish with oxygen. There is an oxygen molecule on its own, and this will be easiest to manipulate, so we often leave it to last. Note, by balancing we get 6.5 oxygen molecules. Guessing a fraction is perfectly fine, and you can carry on with the sum. If you don't want fractions, you could double it. However, you must double everything else as well. Step 2. You must write out the heat formation equations for the compounds in the reaction. Ensure that they are balanced. Remember, it is only the compounds that have heat formation values. Therefore, oxygen gas doesn't have any heat formation value. Step 3. See that butane has been broken down and not formed. Therefore, we must swap it. We represent this by means of an arrow, and we must multiply its heat formation by a -1. Remember, the heat formation values provided are in kilojoules per mole, so we must multiply their values if there is more than 1 mole. Carbon dioxide has 4 moles in the heat of combustion equation, so we must multiply its heat formation by 4. There are also 5 moles of water, so we must multiply its heat formation by 5. When writing the heat formation, be very careful you write the correct heat formation for the correct compound. It is very easy to make this mistake in an exam. Step 4. All other elements should cancel out. This can be done if they are both on opposite sides. If this step doesn't cancel everything out, then you have made a mistake. Step 5. Add the heat formation to get the heat of combustion. Do not forget those units.